Hello students and welcome to part 2 of Unit 7, Part 2, Lesson 1. In this part, we are going to look at two real-world systems and solve them using substitution as we learned in the previous part. The first situation reads, to deliver mulch, Lawn and Garden charges $30 per cubic yard of mulch plus a $30 delivery fee. Yard Depot charges $25 per cubic yard of mulch plus $55 delivery fee. For how many cubic yards will the cost be the same? What will that cost be? So if we start, we can look for the two equations that we're going to use as part of this system. I know that the one will describe Lawn and Garden's charges and the other will describe Yard Depot's charges. Now, I know that these two situations both depend on the same thing. They depend on the number of cubic yards a person wants to purchase, and the number of cubic yards will determine the total cost. Well, the total cost at Yard Depot, which will be Y, will be equal to $30 per, which is multiplication, cubic yards, which is a variable, plus a $30 delivery fee. So our equation for Lawn and Garden is Y equals 30x plus 30. For Yard Depot, it also depends on the cubic yards. So the total cost will be equal to $25 per cubic yard plus a $55 delivery fee. So when we're looking at a real-world application and we think that we can solve it with a system, the first thing that we need to do is define our variables and write our equations. Now we can follow our steps for how to solve a system of linear equations. We know that step 1 is to solve for a variable. Well, if you look at both of our equations, they're both solved for a variable, so we'll just pick one of them. So I'm going to use this first one. Step 1, I know that y is equal to 30x plus 30. So that means y has exactly the same value as 30x plus 30. Now I'll take that value, this is step 2, and substitute it into the other equation, which is y equals 25x plus 55. So instead of writing y, I can write its equivalent value, which is 30x plus 30, which will be equal to the rest of the equation, which is 25x plus 55. Now, unlike our other examples in part 1, we do not have like terms on the same side. In this equation, we have like terms on opposite sides. So we're going to eliminate one of those like terms, and I always choose the one with the least value. So I'm going to take away 25x from each side. 30x minus 25x makes 5x plus 30 is equal to 55. Two-step equation, take away our constant. So we have 5x equals 25. Divide by 5, divide by 5, x equals 5. Remember, x stands for cubic yards, so this is talking about 5 cubic yards. So this was step 3. We solved for our first variable. We now need to take that variable and substitute it back in to figure out what our other variable is. I'm just going to use the first equation. So y equals 30x plus 30. Instead of writing x, I can write 5 because 5 has the same value. So y equals 30 times 5 plus 30. So y equals 30 times 5, which is 150, plus 30, or 180. So our solution to this system is the order pair 5, 180. We now need to interpret that. Go back to how we defined our variables. So 5 is the number of cubic yards and 180 is the total cost. And remember, this is going to be for both companies. So for both companies, the total cost of 5 cubic yards of mulch is $180. Let's look at one more real-world situation. Angelo runs 7 miles per week and increases his distance by 1 mile each week. Mark runs 4 miles per week and increases his distance by 2 miles each week. In how many weeks will Angelo and Mark be running the same distance? What will that distance be? Well, I can see by the question the two variables that we need. Number of weeks and distance run. Now, I know that the running distance depends on how many weeks the person has been running. I also know that we're trying to figure out when they will have the same distance, so I know that we're looking for when the two will be equal. So let's write one equation for Angelo and one equation for Mark. So Angelo's total running distance will be equal to 7 miles per week, and he will increase by 1 mile each week, or 1x. So our equation is y equals 7 plus 1x. You could also rearrange that and you could say y equals x, 1x plus 7. It will not change your value because addition is commutative. Now let's write an equation for Mark. Mark's total running distance is equal to 4 miles per week, and he increases by 2 miles each week. So that's 2x plus 4. Now, step 1 is already complete for us. We have a variable all alone. Y is equal to x plus 7. So y has exactly the same value as x plus 7. Now, step 2 is to take that value and substitute it into the other equation. So y is equal to 2x plus 7. Always making sure you're using different equations. So I'm going to substitute this in here for y. So I have x plus 7 instead of y is equal to 2x plus 4. I have like terms on opposite sides, so I'll take away x from each side. I have 7 equals x plus 4, or 1x plus 4. Subtract 4 from each side, and I have 3 is equal to x. So now that I've done step 3 and solved for a variable, I know that x has a value of 3. I can now take that value and substitute it into one of the original equations. I'm just going to use the first one to figure out what the other variable is. So I know that x has a value of 3, so y equals 3 plus 7, so y equals 10. So the solution is the ordered pair 3, 10. Now remember what this means. 3 weeks, 10 is the running distance, and we know that their running distance is in miles. We also know that this system represented their same distance. So after 3 weeks, both Angelo and Mark will run 10 miles. So let's summarize the steps that we've been taking to solve using systems. First, solve an equation for one variable. afterwards, substitute that expression into the other equation. Make sure you're using the other equation. Third, solve the equation by getting the variable all by itself. That'll tell you one value. Then plug it back in to find the other value. And be sure to check your solution. It allows you to know whether your answer is correct or not.